There are a lot of decisions that go into building the ideal smart home. You have to consider how you'll monitor things, which devices to use, and what control system will best suit your needs. In my opinion, one of the most important foundational decisions you need to make is your home network. If your home network sucks, the work you spend building out your system will fall apart. In this video, we'll go over the different types of networks you may want to use in your smart home, as well as the best way to design everything out so that you'll have connectivity to all of your devices, keep the connections rock solid stable, and give yourself room to expand. My name is Steve, and this is it-alchemy. Most homes nowadays have some kind of network. Typically, this is pretty simple setup consisting of a modem provided by an internet service provider and primarily used to access the internet. In some cases, the modem also functions as a router, and you can plug in your computer or your laptop directly into it. Oftentimes, they'll also provide Wi-Fi as well. This is great for most people. They'll have a computer or two, some phones and tablets, and surf Facebook and YouTube all day. And that's fine. Where this really begins to break down is when we scale up. The modem/Wi-Fi router that your ISP provides you usually only has a few Ethernet ports, and it limits the number of devices you can physically connect. The Wi-Fi, only originating from a single point, can also lead to spotty connectivity for all devices further away, or worse, can get oversaturated by high bandwidth consumers such as cameras. In the modern smart home, there are many devices that need to communicate with each other, a central control system or hub such as Home Assistant, and the internet. Some of these devices are wired, some are wireless, some are neither. So how do you set up networking and connect everything? To help you better understand what will work best for your setup, first let's go over the different types of connectivity and protocols. Connectivity refers to the method of connecting a device. This can be wired via a cable of some sort or wireless. For wired connectivity, you will typically find three main types. First up, you have the most common, which is Ethernet. Ethernet is an extremely fast and reliable protocol and can provide anywhere from 10 megabits a second up to 10 gigabits a second or more. Devices are connected to each other over a standard RJ45 connector and categorized cabling, which you may have heard of referred to as Cat5, Cat5e, or Cat6 cables. These are also commonly referred to as twisted pair cables for a reason. Reason being, each cable has 8 conductors arranged in 4 pairs of wires twisted together. They can also be labeled as UTP, unshielded, or STP, shielded, referring to whether or not the individual wires are shielded. Each category of cabling is rated for different speeds and applications. Each can be up to 100 meters or about 300 feet in length and can deliver speeds shown here. One thing to note here is that bandwidth is inversely proportional to distance. The higher the speed, the less distance it can travel at that speed. For example, if you have Cat6 cabling, you can run 1 gigabit a second up to 100 meters, or roughly half that at 10 gigabits a second. If you wanted to run 10 gigabits for the full 100 meters, you'd need to use Cat6A cabling. In most cases, your home network is totally fine running 1 gigabit a second across the board, but I would recommend at least Cat6 cabling to give yourself some wiggle room for future expansion. As an added benefit, PoE-capable devices plugged into a network switch capable of power over Ethernet can be remotely powered by the switch. Next up, we have MoCA, which is multimedia over coax. This uses a coaxial cable like RG6 to transmit data. It's the type of cabling that you'll find with cable or satellite TV. A MoCA network can be combined with an Ethernet network by using an adapter. This is useful because many older homes are already pre-wired with coaxial cabling, but few are wired with twisted pair. Something to keep in mind is most MoCA networks are limited to about 2.5 gigabits a second, and it could create a potential bottleneck on that segment of your network. Additionally, the inclusion of coaxial splitters can also reduce the signal strength and in turn reduce the total throughput, resulting in lower speeds. Another type of network is called Powerline networking. Powerline networks also require adapters, but they work by sending and receiving signals over your existing electrical wiring. This is great because while you may not have existing wiring for twisted pair or coaxial cables, you'll certainly have electrical wires. While this can be useful to easily add a network to your smart home, I would recommend only running it if traditional cabling is out of the question. The primary reason being that there are a lot of potential impacts to the speed and latency of a Powerline network. Powerline adapters need to be on the same circuit, and things like power strips, surge protectors, and even other electrical devices can interfere with the signal and cause a degradation or loss of signal. Additionally, if your home is anything like some of the places that I've lived in, a circuit could have any number of things running on it and meander all over the house before it gets back to the breaker, so it's not always simple to troubleshoot what's impacting the signal. Now on to wireless. Wireless is by far the easiest to set up, and the one that most people are familiar with is Wi-Fi. Wi-Fi allows wireless communication between devices and has incredible range and bandwidth. It comes with several versions, most commonly referred to as the Wi-Fi version, the IEEE specification, or the band that they primarily run on. As you can see here, there have been a lot of versions over the years, and improvements to each lead to increasing the radio frequency range in order to accommodate more devices and more bandwidth. Something to consider is which devices you'll have on your network and which wireless frequency they support. For example, if a device only supports 2.4 gigahertz, it won't be able to connect to a 5 gigahertz network and vice versa. This is not to say that you can't run multiple wireless networks on different frequencies, and it is pretty common to do so in order to accommodate the widest range of devices. While wireless signals are great for easy connectivity, something to watch out for is interference. Lower frequency signals such as 2.4 gigahertz are prone to interference or noise produced by other devices of the same frequency range. Certain appliances, such as cordless phones, even your neighbor's Wi-Fi network, can interfere with that signal, resulting in lower bandwidth or dropped connections. While they don't have quite the range, signals in the 5 gigahertz and 6 gigahertz range are much less prone to interference and have considerably more bandwidth, so try to choose devices compatible with those frequencies to maintain a reliable network. And speaking of range, another thing to think about is that while all wireless signals can penetrate through solid objects, they can be impinged by certain materials. Solid metal, concrete, and in some cases, windows with low E coatings can limit or block the wireless signals. It's best to position your wireless router in a central location in your home to provide the best coverage and limit the spillover. Another wireless technology you may be familiar with is Bluetooth. Bluetooth also operates on the 2.4 gigahertz frequency, but it's a much shorter range. In most cases, it's only practical from about 1 to 100 meters. While it doesn't have anywhere near the bandwidth of Wi-Fi, it does use considerably less energy. Because of this, it makes it ideal for devices that are on a battery. Additionally, Bluetooth does have a bit of latency. This is particularly noticeable when issuing commands to devices. They're a little bit slower to respond, or when streaming video. The audio and video can be slightly unsynchronized. Next up, we have Zigbee. Zigbee is another wireless protocol with a huge number of manufacturers that have adopted it to their devices. It has a similar range to Bluetooth, about 100 meters indoors, or sometimes even double that if it's outside in the open. Where it differs is the way that it communicates. Zigbee devices use a standard communication protocol, so as long as the device is Zigbee compatible, every other Zigbee device can understand and control it. Zigbee devices function in what's called a mesh network, meaning that devices communicate directly with other devices. It does require a hub in order to control the network, but this is great because it allows a shorter round-trip time when commands issued, resulting in a more responsive device. Also, redundancy: if that particular segment of the network is down, it can still likely reach the intended device through another path. Think of it kind of like multiple streets to the same destination. Similar to Zigbee, we also have Z-Wave. Z-Wave also uses a hub in a mesh networking setup to interconnect devices. It runs on a lower frequency than Wi-Fi or Zigbee, so it's a little bit less prone to interference from devices running on those networks. The largest difference is where interoperability is concerned. Z-Wave products are certified by a single organization, meaning that if it's a Z-Wave certified device, it will work with the entire ecosystem. This sounds a lot like Zigbee, but I'll point out that they had little to no interoperability standards back in the day, so there's really no guarantee that a thing would be compatible. This is much less of an issue today, but be wary when using older Zigbee devices. Lastly, we have the new kid on the block, and that's Thread. Thread is a low power, low latency, low bandwidth protocol that does not require a hub or a bridge. Any Thread device can talk to any other Thread device, which makes communication much faster. Another key difference is that it's also an internet protocol. This means that it can connect to any other IP devices such as computers and phones. Thread is specifically built for IoT and smart devices. It's a low resource overhead, and the ability to scale up to hundreds of devices make it an ideal selection for wireless protocols. Thread is still a recent addition to the smart home ecosystem, so it's not widely adopted by most manufacturers yet, but I expect that to change in a few years. So what would I recommend for the best network setup? Well, that entirely depends on your needs, your budget, whether or not you can modify your house. In my opinion, using wired devices wherever possible is the best combination of speed, reliability, and security. This is especially necessary for high bandwidth consumers like cameras. As an added benefit, using a network switch capable of power over Ethernet gives you the ability to remotely power PoE capable devices. It's much easier to run a Cat6 cable to most locations than it is to run power. I would advise staying away from MoCA and Powerline networking whenever possible. They're useful in certain situations where no other method of connectivity is possible, but in my experience, they really underperform and troubleshooting can be kind of a pain. For wireless connectivity, you want to ensure coverage across every part of your home, and the most single Wi-Fi sources will struggle even with small floor plans. There are several solutions that involve a wireless mesh, which is essentially a base station and one or more satellite stations that rebroadcast the Wi-Fi signal. The better ones have a hardwired backhaul from the satellites to the base station, and others have a dedicated wireless channel, usually on a different frequency for the same purpose. In my experience, you're never really going to get extreme speeds with these. My recommendation is to run multiple access points and strategically place them throughout your home for the best coverage. This seems like a lot of different technologies and hardware to deal with, but luckily, there's Ubiquiti. Ubiquiti is a networking company that provides professional and enterprise class hardware for a fraction of the price, and it's ideal for prosumer smart home enthusiasts like ourselves. In my opinion, Ubiquiti equipment is no more difficult to set up initially than any consumer grade networking stuff, but because the professional features it has can be a little bit overwhelming. I'll do some future videos going over the setup and configuration of these devices. As for Zigbee, Z-Wave, and Bluetooth, the functionality is already built in if you're using, say, a SmartThings hub or a Habitat. If not, it's pretty easy to find USB dongles with a compatible radio that you can connect to a smart home controller such as Home Assistant. You can also find small hubs or bridges that can interface with Wi-Fi only systems like Alexa or Google Home as well. Hopefully I provided some useful information for you to design out your smart home network. Remember that no matter how well you plan something out, you'll likely run into issues that you'll need to work through, so don't get discouraged if something isn't working right away. Smart homes are a constantly evolving process, and that changes as you do. Please remember to like this video and subscribe to my channel. Check the links in the description where I provided some of my kits with recommended devices. Stay tuned for next week's video and keep an eye out for an announcement on the opening of my new website. Thanks for watching.